I'm going to talk about the project we've been working on for about a year now, but first I'd like to say a couple of words about my favorite subject, this guy. That's the biggest I've ever seen my face before. Had to take this opportunity. And I'm mainly a technical guy, but I sometimes venture out of my comfort zone to do workshops or trainings or speaking at conferences. And I like good quality whiskey, beer, and music, and bad jokes. And whiskey and beer and music we're going to have tonight, and bad jokes we are going to have immediately. So I work for a company called Houston, and we're a software consultant company. This was our first project with Magnolia. So it's kind of hard to compare this to what Magnolia projects usually are like because we had no prior experience. But since then, we have grown a bit. We now have 3 certified developers. And we mainly work for Finnish customers, but if you have need for good Magnolia developers, I'm sure Tommy and Tommy would appreciate your message. So, our client unfortunately gives out reference permissions only rarely, so we didn't get one. Bummer. But we'll refer to them as clients from now on. I'm not allowed to say their name, but who knows? Maybe in the evening, if you buy me enough beers, it might slip out. Who knows? I'm already wearing my party bracelet. So they're not a small company, at least by Finnish standards. They have about 20 million customers in over 10 countries, and they have a revenue a bit north of 10 billion euros. The project was called Portal Platform Renewal, or PPR for short. It was basically a migration project, but it was also a complete redesign of the site. You see, it was previously running in multiple systems, one of them being a legacy PHP CMS, one of them was a Magnolia 4.5, and there were other smaller systems which were behind a load balancer that distributed the load to all of those content management systems. So we redesigned all the content from the old system completely and rebuilt them on the bleeding edge 5.4 Magnolia. And we didn't have any prior experience with Magnolia, but we were lucky to have a really understanding customer who said, look, we know you guys aren't Magnolia gurus yet, but that's okay, neither are we. Let's learn this thing together. How cool is that? And we weren't the only team doing this effort. There were also a couple of other teams working on other parts of the site. And they were from 3 different countries. One team was working on the help and support section. Another team was working on the e-commerce part of the site. And there was a lot of content to migrate. There were hundreds and hundreds of pages. We're not sure even how many pages there were because there have been pages buried deep inside the old CMS systems that nobody seems to be keeping track of. And there's a lot of integrations. There are, I think, 12 integrations at the moment. That's just on the backend. We have some integrations on the front end as well. Mostly the integrations just pull stuff out of some other external or internal system and pull that into a content app where we can edit and enrich that information so it can be shown on the site. And we have quite a few servers as well to keep the site from slowing down when we get a lot of visitors. We have a caching layer in there, and we have run some load testing on multiple load test clients to see how much load it handles, and it seems to be handling about 500 page requests per second without even showing up on the CPU usage charts. We faced quite a lot of challenges during the project, but it can be mainly distilled down to these 3 categories: concurrency, variety, and robustness. And there's a lot of moving parts, both technically and design-wise. There's lots of prototyping going on. The designers want to try out new stuff, so does the marketing. We needed to be agile but not fragile. And we wanted to move fast but not break too many things, because that's not always desirable, no matter what Mark Zuckerberg says. There's one Magnolia feature that we thought was fundamental in addressing all of these light modules. It came out on 5.3, 5.4, obviously, which was luckily released just a couple of months before we started really doing the front-end part of the project. And as many of you know, they allow building Magnolia modules, and especially front-end related, with no Java code. We just create a flat directory structure with flat files, YAML configuration files, and free marker templates. And no messing around in the configuration app either. So here's a trimmed down version of what our directory structure looks like in our front-end project. There's a couple of important, interesting points. Hope we can see the text back there. Right at the top, we have Magnolia modules, and that's our output directory. That's where the large modules will go when we build them. Then we have the gulp folder. That's where we keep our build scripts. If you haven't used gulp before, I urge you to take out your laptop right now and install it because it's awesome. And node modules, that's for our npm dependencies. And source, that's where we keep everything that eventually ends up in the target directory. And most of our work takes place in the dialogues and the templates directories under the source folder. And we have all the page and component definitions and their templates in pretty much the same format as we would want them in the final large module. And in addition, we also have the SAS files, our style sheets, and the JavaScript files. We have isolated the JavaScript so that each component has their own bit of JavaScript, which they will use. And they eventually get copied into the Magnolia modules directory. And that actually, we have the gulp build process running all the time. So whenever any file changes, all these files get rebuilt and installed into Magnolia modules. And we have it mapped as our local Magnolia installations resource directory. So Magnolia will pick up those changes immediately. When we change anything, we just reload the page in Magnolia and see those changes right away. And there's also the test folder for our unit tests. Every time we save something, we run the unit tests. We are running Karma and Mocha. And they will detect any changes in how the tests are running, whether they run without errors or with errors, and report immediately, so we don't actually have to ever ship broken code. So, how does this setup help with our concurrency problem? That's our team right at the top left. Everybody has their own private GitHub repository that they have cloned to their computer. And when we change something, and we consider it ready enough to be shared with other developers, we do a pull request via GitHub. And that request is then reviewed by some other developer. And if it's OK, it gets merged to the main master branch. And once it's ready to go to deployment, we push it to the confusingly named Atlassian stash, which has nothing to do with Git stash. That's like a local GitHub kind of setup that's running inside our client's intranet. And that's important because whenever we push code changes to that repository, it will notify the Jenkins, which is running also in the same infrastructure. So we don't need any firewall openings for that. It will run the same gulp build scripts, gulp test scripts, make sure everything is compiling. If it isn't, Jenkins will come to our Slack channel and say, Niko, you bad boy, you broke the build again. Luckily, that seldom happens because we have the tests also run every time we save anything. After the build is finished, we run Maven to build the tarball out of the code. People thought we were crazy building Maven stuff with front-end stuff. But there's actually a good reason for that. You see, our backend code goes to our artifact repository called Nexus, and there are ready build scripts for that. So we thought, why not use the same thing for front-end? So we just store the tarball in the Nexus, and after that, Jenkins will invoke an Ansible playbook, which is a configuration management software, but we use it also for deployment. It will connect the servers we are deploying to, pull out the latest changes from Nexus, and unpack them, and the changes are online. That whole cycle takes about 30 seconds. So anytime we want to deploy something quick, we can just do the review really quickly, maybe pair program, so the review part is kind of built into that. Push the code, go grab a cup of coffee. When we come back, we are online. And we don't have to worry about those teams. They have their own systems back there. They have their own swim lanes. We don't have to worry them breaking our stuff or us breaking their stuff. We only know that we are going to meet in the end on the same server. Now, let's talk about something else. Who likes pizza? Oh, many hands. Great. What is the best pizza? Sorry? Napoli, yeah. Great answer, but wrong. Anyone else? Okay. The best pizza is the one where you get to choose your own toppings. I don't know if it's a global thing, but at least in Finland, we have a pizza that lets you choose any 4 fillings you want. And we call it fantasia, fantasy. That's kind of sad, actually. Our fantasy is getting to choose our pizza toppings. But the numbers don't lie. We have 58% of pizzas sold in Finland are fantasia. The one close behind, at 3%, is Americano. That's pineapple, blue cheese, and ham. But none of these, even combined, are close to fantasia. Pizza restaurants in Finland usually have about 20 pizzas in their repertoire, but nobody ever buys them. People only want fantasia, because people love variety. So do designers. They don't like templates. Ironically, that means we are going to have to build a lot of templates for them, because all of them need to be different. Or do we? After we have been working for this site for quite some time, we had maybe about 5 or 6 page templates. And we were also, at the same time when we were building these new page templates, we were making subtle changes to the first ones. Like, can you make this a bit higher? Can you turn these around? And we thought, this is starting to become a problem. So we thought, this is kind of like we are running a pizza restaurant with 20 pizzas in our inventory, and someone's changing them all the time. But that's when we got the idea. So we made one more page template. It was an empty one, and we enabled all the components on that page. Gave it to the editors and said, there you go. Try not to hurt yourselves. Surprisingly, it worked. They were able to create all kinds of content from our building blocks. You see these screenshots here on the left and right? They have the same page template. It's built completely from the modular components that we provided them. So basically, header, footer, and all fantasia in between. So now we have a ton of components, optimized as atomic as possible for reusability. Many of them are powered by JavaScript. And we have a gulp task that takes all the JavaScript and combines them into one file, minifies it, and spits out a big scripts.js. And that is a lot of JS because we have that many components, so they add up. And it started to get our attention when it grew past about 700 kilobytes minimized. And because the design is so atomic, we needed a way to feed the components data from JCR, from the dialogues. And we didn't find any easy way to do it, and neither for allowing components to communicate with each other. So we made a library. There's a lot of JavaScript libraries, and that's probably because it's quite trivial to make one in JavaScript. So we rolled our own. Instead of one huge blob of JavaScript, we arranged them into AMD modules that can be loaded on demand by our library if needed. It also helps the communication between the components, and it allows us to easily pass data from JCR to the JavaScript. And it also automatically reloads components that have requested to be reloaded when some part of the page or its state changes. It works like this. Our library gets initialized on page load. After that, it will detect all the components on that page that have their own JavaScript and have requested to be loaded. It will load the JavaScript for only those components that exist on the page. It will load their dependencies, if any. And it will build the components, meaning it will call their build function one by one as they are loaded and ready to rock. Let's take a quick look at the code. It's kind of embarrassing to show this example because the only JavaScript for this component is a dirty hack. But we wanted to make that list item at the top clickable. And after a couple of days of tinkering with the CSS and HTML, we couldn't make it just the way we wanted. So we decided, screw this, we're going to do this in JavaScript. So it's called Big 5. Note the data component attribute at the top. That's what the library is going to be looking for. That's the name of the component. And it needs to be in camel case for the automation to work. And here's the JavaScript code for that component. The first 4 lines are required JS boilerplate. The first line tells the name of the module, which has to be the same as the name in the FTL. Note that it's here in snake case, but it can be in any case we want because the library converts that automatically to camel case when it starts to load the code. Next lines, it defines its dependencies. So this component is dependent on our base component, which has some basic functionality that all components share. And it is also dependent on jQuery, which we injected into that. And on line 11, we extend this component from the base component. We have to do that to get use of all the base stuff we have. And from line 16 onwards, we have the build function. That's what gets called when this component is loaded. So it takes this .node, which is the HTML element, which is the root of this component, and it adds a click handler that listens to clicks and forwards them to the first link it can find. Ugly, but it works. And it returns true in the end. If something was to fail when initializing this component, we would return false, and it would remove the component from the page altogether. So let's look at how we pass data from JCR to JavaScript. Here we have the free market template of a custom area, and we need to make the properties of all the components in that area accessible by JavaScript. So we have a function that converts the component's properties to JSON. Our library will give all that data to the component as it gets initialized. And it's the data component data, funny enough name. And we call our own function over there and give it a parameter, the component, and it will go through all the properties that belong to that component, turn it to a nice JSON, and return it to our library. And it will also take out all the stuff we don't want from the JCR, such as anything beginning with MGNL or JCR, because those are internal properties, and we don't want them getting their way to the customer. It used to be a macro. This probably explains why it isn't a macro anymore, because we aren't allowed to have line fades, because this will break the data attribute. Luckily enough, we found a way to do it as a function. So it will go through all the properties one by one, and if they are properties that we want the component to have, it will make a nice JSON out of it and return it. We also have a simple messaging feature in our library, since we have components that need to communicate with each other and to be able to receive global events such as page loaded or user logged in, so we can, before the all the dependencies are loaded, we can watch for events that we want to inform to analytics. And when the page is loaded, we'll just take all of that queue and send them all to the analytics engine one by one. So there's no slowdown for any of that. And we have an embedded Spotify player on the page that has been divided into two components. There's a playlist component and a player component. And when the user clicks on the playlists in the playlist component, it will need to start playing the songs on the player component. And we have also, in this example, we have the custom area we were looking at before. It contains components, graphical components, that may contain images, shapes, text, anything. And we want them to be parallax scrollable, meaning when we scroll the page, they will either be faster or slower than the rest of the page, giving it a nice 3D touch. And we are using a library called Stella for that. And the child components need to call their parent when they are done to be initialized. And each component also has their own event queue, and there's a global queue that all components can post to and listen to, and that's where we get information for when the user logs in, so we can reload all the components on the page when that happens. And that's how that is done. We got the href right there. That's because in Magnolia, all components can have their own URL where they can be loaded individually. And that's what we took advantage of when we came up with this solution. So that's actually a Magnolia built-in feature, this cmsfn.link content, that gets us the direct URL of the component we are rendering. So if the component has that, whenever we get a reload components event, we reload that page. We do an AJAX call to that address, read out whatever is coming out of there, and replace that component content with that. As long as the attribute is present, that's handled automatically by our library. So I hope this has inspired people enough to ask the question, is it open source? And the answer to that question is, well, yeah, it will be in the future, but we have a couple of things we have to work out first. Most importantly, it needs to have a cool name. PPR won't do, it only makes sense in our context. I was hoping to call it Pepper, but that's apparently already taken, so we can't use that. If any of you come up with a great name for a library, please let me know. We'll be happy to use it. Pepperoni, brilliant! I owe you a beer. And also there's another problem. We were mapping out the internal dependencies of the library and noticed there were quite a lot of them, and some of them were circular, and we are going to have to sort that all out before we are ready to release it to the public. So that's what light modules get us. Before Magnolia 5.4, we would have to use XML, version handlers, and all that sort of stuff to get this stuff to the other developers. Now we just create a couple of files, add them to version control, and we're set. We're able to do reviews on those codes and quickly see what's new. It's trivial to work in branches if we're working on multiple features at a time. Most importantly, if someone breaks something, we can find out who's guilty. Git blame and git bisect, my two best friends. We can run tests every time we save. That makes testing so much easier because it's done all the time. We don't have a deployment window. We took a jackhammer and took the whole world down. We can deploy whenever we want because it only takes half a minute. Everything is highly decoupled and modular. No problem with a high amount of components. Thank you so much.